Hi, my name is Yuzhu Ku, and I work on front-end graphics. So today's talk, I'm going to talk about some new features, new updates about the graphics language. So my name is Yuzhu Ku. I work on front-end graphics. So today I'm going to talk about some updates about the graphics language. First, I'm going to talk about some of the new features of optimizations will come with version 12, sorry. And also, after that, I'm going to talk a little bit more beyond the 12. The first is the local graphics complex. So before we have the graphics complex, and you can specify the complex coordinates and the index specified in the primitive. Okay, sorry. Is this better? Okay. But now, for some cases, it's not very convenient for the nested boxes. Now we have the syntax to put them together in the same primitive box. Have the complex and then have the index. These two should behave exact same. Looks very straightforward. And here comes the options. So for previously, the options go with the graphics complex. But with a new syntax, you can specify with the primitive directly. And this syntax will be supported by most 2D and 3D primitives in version 12. Next, Polygon with hosts. This has been requested many years in different forms, but now we have something. It is available as a new syntax as a polygon. So you can define the boundary of the polygon, and together with it, you can associate it with a bunch of hosts, multiple of them. And you can also specify with the local graphics complex way as well. These are 2D and 3D examples. And yeah, so you can try to edit and notice that the overlap part will just work as it should be. This is 3D case. So for options, we supply two ways. One is automatic, the other one is explicit. When for the automatic case, it will allow the user to do exactly like a paper cut. And you don't need to worry about the attribute inside. And the other way is you can specify explicitly, and it will be respected. I can see some difference there. And it will work with both texture and vertex colors, and for 3D, we work with the vertex normals as well. Here are a bunch more examples, slightly more complicated. The boundary can be concave. The hole itself can be concave as well. Let's try to play with it. You see the part the edge get cut will not show up. And yeah, and if there's something go over, this part will be not show up as well. And here's another example with slightly more complicated polygon. The polygon itself is intersecting with himself, and the hole itself are stars as well. It works with itself or with different options. So bounding sphere, previously we always have the concept of bounding box. But for some cases, people don't specify the box and the axis stuff. Probably you need a bounding sphere concept. You can specify that with the spherical region and with user coordinates. If it is specified, the view center and the view angle will be preceded. But it is good that you don't need to struggle to figure out what is the right view angle. Here's the examples. The videos. This is 1, this is 3. And this is another example with anatomy plot 3D. This is the model for the whole human being, and you can just choose to visualize the part you want. So we have several optimizations and new options with Raster 3D. The first one is sample. So sometimes you have very low resolution voxel data, and that will end up very blurry result, like this. So now we added this option. You can control to control that. What it does is it will resample your input data to at least this minimum size. So you can see if you improve this size will get much sharper. And we also did some optimizations combining Raster 3D and other transparent graphics 3D. Before it was slow. Now it should be, if there's no overlap, it will be just as fast as the single Raster 3D. Transparency. So transparency is expensive, and we are among those very few companies where treated this very, very seriously. We try to make all the transparent polygon render correctly. And in the history, we use the BSP tree, which is a splitting of polygons into tiny pieces so that you can sort them. Consumes a lot of memory and time as well. And then we come with the multiple pass depth peeling. We don't need to sort. But you need to render multiple times because each time it only peel one layer off. Now with the hardwares and the newer technology, which is OpenGL 4.2, we are able to do single pass depth peeling. So you just need to render once, and you will get all the layers. Here are some data collected on my 4-year-old laptop. And you can see, compared to multiple pass depth peeling, the single pass depth peeling will be slightly 4 to 5 times faster. This is like a several million polygon model. And while we are adding new features, we are also trying to optimize polygon, both the memory side and the performance side. And here are examples I will try to provide different plot points. The plot points can choose the sample points in both x direction and y direction. So if run these examples in version 9, my laptop, Windows 64-bit with 16 RAM, it can only reach like 1500. And after a long waiting, it is not very responding. With 10.4, we did some rewriting of the low-level code, and it rendered more polygons, and the performance improves a lot. I'll keep improve in 11.3 and the version 12. We also keep optimizing the memory side. So compared to version 9, it's around 3 times more polygons. It's both X and Y direction. So surface appearance is a directive which allows you to do a lot of low-level shading language stuff. What you can do with it is you can customize your own rendering with the shadows. It works with both 2D and 3D, and it works on all platforms. Currently follow the GR/SLAM 1.2 standard. And now it takes the association syntax, and it will be more straightforward, more readable. So here's the name. Attribute is something attribute you want to get from primitive, like the position and vertex normal, vertex colors, and the vertex texture coordinates. And then parameter is something you can provide yourself, define it yourself. You can call it directly in the shadow. You can also inherit it from some of our built-in directive and options as well. And more important, you need to specify the shadow program for both fragment and the vertex. So these seems very low level, gives you a lot of flexibility. So what can you do with it? I will show you 2 examples. Shadow is currently the feature we don't have in our graphics language. We will see how we can do in surface appearance to achieve that. Shadow mapping is a 2-pass rendering method. The first pass where you will get a depth map from the light source eye. And then at the second pass rendering, you use that depth map compare to decide which area is shaded, which is not. Because the depth map shows only the closest object depth. So to do that, you probably need to define a bunch of metrics to convert user coordinates into, like for example, lighting source space. And we add the definition. The first one is the first pass to generate the depth map. And this is the second pass. And it will have some lighting computings. I simplify that to use that simple directional and point lighting. And it is totally customized. And now you need to define the 2 pass graphics. First pass generated the depth map using surface appearance, which is defined previously, and also the shaded graphics 3D, which is, does everything. And since it's a 2-pass method, the first pass result need to be passed in texture and use it in the second pass. So now let's just give it some polygons to see how it works. So this is something object, the lighting source coming from here. You'll see it works as expected. And this is the depth map generated from the first rendering pass. Now you just defined customize the graphics 3D, and just feed in some data and see how that works. We just take some data from example data, and you also need to feed in the plot range as well. So you will see this in this example. You will see the shaded area. This is the shadow of this part, and the shadow from this part. And let's try with different data set and see how that works. They will have different plot range and have different data size. it should work with all of them. And please notice this eye area. And let's try a little more complicated model, which is cow. It will take 2 to 3 seconds. Oh, yeah, it's done now. So you will see the shadow of the ear over here, and other parts as well. So which means, yeah, you just make your own customized renderer. And here's another example, it's bump mapping, which is we don't have in our graphics language either. And let's try to see how can we do it with it. So you need to define your lighting model as well. This is a little more, slightly more complicated because this is exactly the shadow used, the lighting model used in front end. It handles all the lighting options, and also different coordinates like scaled coordinates and user coordinates. So you can use them in your defined function. So define a box and give the texture, the normal map as a texture. And you will get something like this. Let's try to see. Please see the highlighted part, the specularity. You can see a lot of depth perceptions and a lot of details there. And this is default lighting, and let's try a different lighting, point lighting. So take a look at this part. You can see it's really a lot of details there because each pixel has its own normal. You don't have to construct a very complicated models for that. You just need to provide the normal map. And it's very fast. So this is another thing you can do with surface appearance. Now I'm going to talk about some new features who are beyond the version 12. We are having good progress with Direct3D11 and Metal, which are new APIs, which allows us access a bunch of new features, both Windows and Mac. Among them, one of the things that it allows you choose different hardwares. For example, currently computers will have integrated, have discrete hardware, and sometimes you might have external one. You can choose between them. And through the preferred GPU option, it will work with both Windows and Mac. And the system information will also show more information. So it will list all the information about the different hardware. So you can compare them and choose between them, and also list the one currently work with Mathematica. Building stereo, and this has been requested as well, and it now works with Direct3D11. And we are doing the same thing. We are doing it in the same way as Unity does this on Windows. So as long as your hardware work with Unity in the stereo part, it should work with us as well. And it will work with any 3D graphics, including the volume rendering, the rest is 3D. And NVIDIA desktop hardware tested their work, but then the mobile one we are not. That's a requirement. And Other than that, we probably will get better text and tick labels. We're getting much sharper text on Windows in graphics 3D. And fast depth peeling will also be supported on both of the new APIs. And there might be more features coming as well. So that's about it. So do you have any questions?